All right. Well, good morning, everybody. I was trying to give my fearless leader, Jim Dotson, an extra second to show up, and I'm sure we'll hear the pitter-patter of his feet directly. But we are here at the Fairbanks Economic Development Corporation. It is Tuesday, November 2nd, if I'm not mistaken, about 8 o'clock in the a.m. We're here for the Energy for All Alaska Task Force meeting to have a true energy discussion again today regarding micro-nuclear and the recent announcement of deployment of a micro-nuclear reactor pending at Eielson Air Force Base. With us today, we have Ms. Gwen Holdmann of the Alaska Center for Energy and Power, one of our favorite local energy rock stars, truly. But here to give us some information, not specific information about specific technology there at Eielson Air Force Base, but an overview regarding micronuclear as ACEP has taken the lead here in the state of Alaska on that item. And we'll shop around over the course of the coming weeks to see if we can get a representative of the military for a follow-up presentation. But for now, we thought it'd be a nice reintroduction to the subject with Ms. Holdmann. So Gwen, if I may, the floor is yours. Thank you so much for coming.
Thanks, Jomo. Yeah, and just to be clear, I mean, I am going to talk a little bit about the Eielson Project and give you guys the information that I have. I don't have any secret insider insight other than having talked a lot to folks from industry, so I can kind of share some of my thoughts related to that. But I actually have a feeling that some of the people that are participating this morning might have a few bits of information to share as well. So if you do jump in on the chat or jump in as part of this conversation. I can't see everyone that's participating right now. So I don't know who's part of the call right now since I'm screen sharing. So the Alaska Center for Energy and Power, most of you kind of know who we are. We work on energy issues that are relevant to the state of Alaska. Nuclear is something we've actually been working on for quite a while. I think that David Lockard is on this call, and if he is with the Alaska Energy Authority, we actually worked with him on putting together a report to the legislature back in 2011. Which we actually just recently updated. And so I dropped a link in the chat on how to get to this report, along with a couple other documents that I'll kind of reference. But you can just very easily get to all this nuclear related materials from our main website. So if you get to ACEP's website, you can get there. And so that report kind of talks a little bit of an overview of nuclear energy at the national and international level in terms of what's happening currently. It's actually pretty interesting because our 2011 report, the amount of activity that's happened, especially in the micro-reactor space in that decade, has been pretty significant and pretty interesting and pretty exciting, sort of culminating with this announcement related to Eielson Air Force Base. So this report gives a little bit of technology updates. I'll kind of run through some of those during this presentation. And then relevant policy at both the state and the national level. And so one of those is that we do have the need to sort of clean up some of our state statutes related to nuclear energy. This is something that we've also been working with AEA and the governor's office and other state agencies on, just kind of taking a look at how we're thinking about nuclear energy at the state level. Right now, there are statutes that, for example, require legislative approval of siting of any nuclear reactor. I don't actually think this project at Eielson per se falls under those restrictions, but nonetheless, I think that there's a real desire, at least by industry, to make sure that they're following up or meeting like state requirements related to deploying a reactor. And so a little bit of an economic analysis, that's where we're starting to see actual pilot projects begin to at least get closer to fruition. So we'll be able to have a little bit of better economics, but we've been taking some shots at that, and then some recommendations for action. And a big one is this formation of a nuclear working group. I said earlier, and some of you may have missed it, our next Alaska nuclear working group, small nuclear working group meeting is next Tuesday on November 9th, and we're actually going to have the the Nuclear Regulatory Commission, the NRC, as speakers there. So I think that's another opportunity. I'm at least going to prep them that they'll probably get some questions about this project because it will be licensed through the NRC. And so go through sort of that approval process, both for the actual technology and for the site. And so they're going to be really kind of mirroring what the expectation would be for any other commercial project down the line in terms of NRC approval, or that's at least my understanding. So this working group is open to any or all of you to participate in on a regular basis or just on a one-off basis. We have the NRC speaking this month, and then next month it's going to be another one of the manufacturers that's been interested in the Alaska market. There's quite a few of them that are out there. There's actually 2 companies now that are part of, that have been participating in Launch Alaska. One of those is Oklo, which some of you may have spoken to, and they're the ones that are kind of furthest along with the NRC process right now in terms of technology licensing. And then the second is Radiant Nuclear, which is another small company that that's interested in the Alaska space, and they're actually participating in Launch Alaska, and they're going to be speaking in December to the working group. So you can sign up for the working group on this website on that link as well, and I think I dropped that in the chat too. So
Just
anyway,
it's easy to it's easily accessible. As you showed, that was the homepage for the website, so it's easy to find and it's easy to sign up. I went ahead and I can't believe that I wasn't already part, but I went ahead and signed up this week or last week. It was really easy, so I'm looking forward to it. Thanks.
Perfect. Yeah, and we've had about 50 to 70 folks that have been participating in that pretty regularly. I'm actually hoping to tap that group eventually to develop a roadmap for the state. And I also want to acknowledge that both the Alaska Energy Authority and the Arctic Energy Office have been coordinating with ACEP on setting up and organizing that working group. So again, like the purpose of this is basically to have Alaskans understand more about the small reactor industry and what's happening in terms of projects, permitting, licensing, environmental, any concerns that we have related to nuclear, but then also to educate stakeholders, not just in industry, but also agencies and national labs about kind of Alaska use cases and potential opportunities for future deployment, but what some of the challenges that we see related to that are. And then again, like this idea of identifying opportunities for demonstrating small nuclear technologies in Alaska that minimize risk and kind of work with sort of the use cases that we sort of envision for our future. So I'll just go through this pretty quickly. I know we did have Westinghouse, eVinci, that has the eVinci reactor. They presented to this group a while ago, but I know that we have sort of diverse backgrounds here. So I'll just kind of mention Alaska does have this history of nuclear technology. Our reports, our 2011 report actually details a lot of the history related to nuclear deployments in Alaska, including the Fort Greely SM-1 reactor, which was a Army reactor, and it was commissioned in 1962, decommissioned a decade later. And so this was really like basically a reactor that was almost out of like a submarine reactor, like highly enriched uranium, small reactor, and it's pretty different than what we're envisioning today in terms of micro-reactor technologies from a safety standpoint, from the level of enrichment of uranium and a number of other factors. And then another area where Alaska really got a lot of national attention, and many of you may have heard about this like concept for a Galena 10 kW sort of a nuclear battery that was proposed. It's been almost, you know, I guess like well over a decade ago anyway. This never went anywhere. This was sort of what we would consider a paper reactor. It wasn't a real reactor. It was a proposed reactor on paper, and it didn't really move forward, but it did result in a lot of pressure on the NRC and federal agencies to really think about, you know, what a reactor would look like kind of in situ in a community, you know, benefiting users. And so this was something that kind of resulted in 7 white papers. There was a lot of interesting information that kind of came out of this, and it really kind of kick-started this, you know, a little bit of a renaissance about thinking about small reactor technology. So a lot of people at the national level are pretty familiar with this project. And then, you know, we do also have this history that many Alaskans are pretty familiar with Project Chariot that was proposed, and then the Amchitka, you know, testing, which was some of the largest underground tests that were conducted by the US military. So we do have that history as well. Now, when we talk about small nuclear reactors, sometimes I feel like there's a lot of sort of word salad, and it starts to get sort of confusing on what we're talking about. You know, a lot of people talk about advanced reactors. There's micro-reactors, modular reactors, transportable, what's a breeder reactor, light and heavy water. You know, there's a lot of these questions about the technology. So I kind of want to break it down just quickly in a little bit. And I'm going to break it down into 3 buckets by asking you guys some kind of fun questions. So these are sort of the 3 areas that I think that are pretty important to like this microreactor technology space. And one is, what do these microreactors have in common with the Trans-Alaska Pipeline? And in the interest of time, I think I'll just answer my own questions. And that is that a lot of them are really based around these concepts for sort of passive cooling, passive removal of heat through these sort of convective currents that are set up. You know, we have on the Trans-Alaska Pipeline, you know, very similar systems working at very different temperature, but like, you know, basically we have thermosiphons that are extracting heat from frozen ground along the Trans-Alaska Pipeline to prevent the ground from subsiding. And for a lot of these microreactors, the way the heat is extracted from the reactor core to be able to be used beneficially to generate electric power, use that for heating, is actually through like heat pipes or passive ways of kind of removing that heat. And so that's like one factor that has a lot to do with enhanced safety related to these small reactor designs. Another part of that is that the actual fuel itself, you know, we really developed much more advanced materials, particularly sort of these, yes.
Before you get any further, your audio is getting a little bit choppy. May I ask that you just go ahead and turn off your video camera, see if we can save a little bit of bandwidth?
Yes.
Not that we don't like seeing your smiling face.
Let me see if I can figure out.
Okay.
Is that better, Jomo? Because I'm a little concerned. I could call in on my phone as well.
No, yes, that helped. Thank you.
Did it? Okay. Guess the university's internet's not so good at.
Well, we have quite a few people on the line.
Okay.
Okay, thank you.
Yeah, no problem. So anyway, one of the things is really looking at the type of fuel and, you know, where you've got these encapsulated fuel particles. They're, you know, very small. It's like kind of almost, in this case, this triso fuel particle. And the idea is that even if there was some sort of a breach of the reactor, that the actual fuel would not come into contact with the environment per se, because these particular encapsulated uranium particles like really cannot be compromised either mechanically or from a temperature standpoint. And so, and again, like the same thing with cooling, a lot of these are really designed with this idea that they don't rely on active cooling of the reactor core or removal of heat from the reactor core, that this happens passively. And that's a pretty big deal because a lot of the nuclear accidents that we have seen historically, whether that's Fukushima or Hiroshima, a lot of those are, I'm sorry, Fukushima, or anyway, they are occurring because of the fact that you have some sort of an uncontrolled meltdown of the reactor core. So if you've got this passive system where you don't have a need for active cooling, that really helps alleviate some of those safety concerns. And especially having a smaller amount of nuclear material in any one place really helps with this as well. So secondly, what do microreactor technologies have in common with the automobile industry? So the big one here is that they are, you know, and this was a big deal for the automobile industry in terms of like making these, making cars affordable to common people, and also like having real quality control by having them produced in a factory in a really controlled environment by people that were experts in assembling and manufacturing these components. And the same thing with these micro reactors or these modular reactors. The idea is that they're mostly designed and built in a factory under really controlled conditions and in a way that that you can really bring down those costs because you have sort of a factory assembly process down the road for these sorts of technologies. So this is an example of NuScale. This is a concept that's been around for quite a long time, and the idea here is that this would be sort of a replacement for our sort of gigawatt scale reactor technologies or nuclear plants that are kind of a big part of our national utility power generation in the lower 48. The idea is that here you would have like 6 or 12 different reactors that are part of like a larger system. So this is kind of what we consider to be a modular reactor design, where you have multiple reactors that are working together in a larger reactor, but they can be worked on individually, they can be controlled individually. And even with these micro-reactors, it's also the vision of the manufacturers that a lot of these could be deployed in multiples. So even if you have a small reactor, like we talked about earlier, the eVinci reactor is a 5 megawatt reactor, you could have multiples of that making up a larger plant. And so the third one, what do micro-reactor technologies have in common with diesel generators? And this is another area that I am pretty excited about. And that is that they can load follow. And so that is something, as we're looking at increasing the amount of renewables on this grid, that's a real challenge. Like for Golden Valley, if you even have, you know, a swing of, as I understand it, even less than 10 megawatts, you know, in terms of generation or load, you start to like really have some challenges in terms of like maintaining power quality on our grid. And so here's an opportunity to take a technology that actually is designed to potentially do some load following. And there's a lot of questions that we have about this that relate back to the economics, how quickly they can respond, can they actually really provide regulation for renewables, and what role might they play in terms of the future of the rail belt grid and incorporating renewables. So we have a lot of questions. The big one really in my mind is a lot about the economics. As you're kind of backing off a system, and you're saving some fuel, how does that actually play with the larger scale long-term lifetime economics of a system? But this is something that's pretty exciting because in general, in the rest of the country, our nuclear reactors are really designed to base load. They kind of provide a lot of the base load power generation for the country, and they don't have that much ability to fluctuate up and down in terms of their output. So some of the reasons I'm interested in this, and I don't want to spend too much time on this, but this idea of providing not just heat, but also, or not just power, but also heat, carbon-free, potentially safer. We don't know about the pricing. That's a big unknown, but that's certainly something that is the goal of industry, is to be competitive in terms of pricing with status quo technologies. So, and then just because the fuel, because these systems don't need to be refueled that frequently, you have more certainty long-term in terms of like your fuel costs that you might have. This is especially relevant to places that are sort of diesel dependent, where that cost can fluctuate, not just from year to year, but within a year, just based on the lift date of when the fuel was actually put on a barge and shipped to a community, for example. Reduced risk of environmental contamination. One of the things that I think of a lot is that our status quo generation, whether that's diesel in rural Alaska or other forms, there is you know, sometimes environmental contamination associated with that, especially lightering diesel fuel. There's been contamination around that. So we have to kind of do a comparative analysis of status quo to like new opportunities. And I think it's important for people to really have a clear understanding of what the potential risk of environmental contamination is. And so again, and then a possible complement to our existing energy resource mix in Alaska. So that's why I'm interested. This is actually a chart that we created for a 2011 report, and this was about which small nuclear reactors were under development in 2011, so a decade ago, that were under 300 megawatts in electric power output. And one thing that's really interesting is that a lot of these are no longer in existence. They're not technologies being worked on anymore, including that Toshiba 4S reactor. The other thing that was interesting a decade ago is that there's really nothing in this small range here. So like 0 to 50, megawatt size that would be more ideally suited for an Alaska application. There really was nothing being worked on in that size range. And now in the decades since then, that's changed pretty significantly. So if you look here, this is their kind of updated report looking at the size of these reactors. And so you can see that there's a large number of them that are actually under 10 megawatts, something around a dozen or so that are being developed or that are seeking approval through the US NRC process. And then there's still these that are kind of of the larger size too. A lot of those are sort of more modular reactor designs. But it's actually pretty exciting because there's been a lot of advancement, a lot of things happening in sort of this smaller scale range down here. So nationally, and I guess in North America, there's really two sites that have been identified.
Gwen,
yeah.
I'm sorry, I had myself on mute. On the last slide, just for a sense of scale, 10 megawatts, where would that fall as far as, like, say, community size at base load?
Yeah, that's a great question. I actually have a slide later to look at communities across Alaska, but to give you an idea of that, the university's new power plant is a 20 megawatt plant in terms of electric output. And like Eielson Air Force Base is also, I think, around 20 megawatt. And then but it's kind of its typical load is more like 12 or 13 megawatts, as I understand, just to give like a rough idea of that.
Okay, thank you.
Golden Valley is like more like over, like around 200 megawatts. Does that help?
Yes, miss, thank you.
So in the U.S., one place that's being viewed as a site for potential testing of microreactors is at Idaho National Lab, and then internationally in Canada, there's Chalk River Laboratories, and so those are the two sites that are really being looked at in terms of technology testing and potential early pilot deployment of these microreactor technologies. But now, of course, we're also looking at some of these field deployments as well, and I'll talk a little bit more about that. And I should mention that there are some companies that are choosing to go through the Canadian process rather than the US process. One of those is Ultra Safe Nuclear Corporation. They're actually quite interested in the Alaska, in Alaska as well, and I'm sure they'd be happy to come and speak to this group. They've spoken in front of the nuclear Alaska Nuclear Working Group previously, but they're actually they're a Seattle-based company, but they're choosing to go through licensing in Canada first. Although, like I mentioned, they're very focused on the Alaska market as well, and their reactor design would be like 10 megawatts. Although the last time I talked to them, they're talking about like more of like a 20 megawatt design. So there's always a little bit of, you know, they're always mixing it up a little bit. So, okay, so going into the Eielson project. And so again, like full disclosure, I said this earlier, I don't have any secret information or insider insight to share with you guys on this. There may be others on this call that can, and I would love to hear from them. I did actually try to reach out to folks both at Eielson and statewide, and didn't have luck doing that yet, but we're hoping to get some additional answers later. We'll see. But anyhow, this really comes out of I say here 2019 with the NDAA, but actually it even really predates that. Like in 2018, and I dropped a link in because I was reading this report earlier. The Nuclear Energy Institute developed a report in 2018 looking at what it would take to deploy a microreactor on a base. And this is sort of the nuclear kind of technology group, industry group. So it's industry representatives. They work with industry to develop this report. And they sort of, I realized, baseline to Eielson in this report too. So it's kind of interesting. It's kind of going back to 2018. They also had a pretty significantly a faster timeline for moving the process forward than what's actually happening. But anyhow, this kind of dates back to the 2019 frame where there was this desire to sort of start thinking about what one microreactor would look like for DoD, and that was refined last year by this Executive Order 13972 to promote small modular reactors for national defense base explanation. There's kind of a quote from that executive order. It's the policy of the United States to promote advanced reactor technologies, including small modular reactors, to support defense installation, energy flexibility, and energy security. So that's just kind of a quote from that. And so there was an RFI process that was conducted between September and December of 2020. I think that Eielson's really always been the leading candidate for potentially hosting this pilot. I know that industry has often spoke about Eielson as a likely site for this. And so it's managed right now through the Office of the Deputy Assistant Secretary of the Air Force for the Environmental Safety and Infrastructure. That's kind of a mouthful. So anyhow, let's see here. So why Eielson Air Force Base? So first of all, as I understand it, Eielson is, of all the Air Force bases, it is the one that has the highest energy costs overall for the Air Force. So the reasons are this idea about resilient power needs for mission assurance. Eielson has limited access to clean energy. We've actually worked with them several times on different sorts of assessments for what their options are for incorporating renewables. There really are fairly limited options, at least co-located with the base. And so that's a challenge in terms of the Air Force's or the DoD's commitment to reduce carbon emissions over the next decade or so. And then the other big thing, I think, is that the existing energy infrastructure and then compatible climate is what they say. But really, when you kind of read between the lines there, a 5 megawatt electric reactor output, in terms of the thermal energy available, it would probably meet all of the base's needs in terms of thermal energy. And I think that that's actually kind of an interesting match, actually, when you look at the size of this reactor and the base load. It wouldn't provide all of the electric power needs for Eielson. It's less than half, but it would hypothetically be able to produce all of the heat, meet the heating needs for the base. And this is Gwen's perspective. This is not something I read somewhere. So if someone can correct me, but that's sort of something that I observed anyway. So this project is not designed to be grid connected, although I don't know who's on from Golden Valley today, but I talked to a company yesterday that wanted to know if Golden Valley was interested in owning a nuclear reactor. And I said, talk to them. So, but the idea is here that this, at least for this pilot project, it will not be grid connected, but it is intended as kind of a commercial deployment. So this question about who the owner and operator would be is kind of an open question. Obviously, there's going to be a lot of folks engaged in this kind of a pilot project, including the vendor to start with. But there is sort of a question about the ownership structure related to this. And that's one of the big questions I have. It will be licensed through the NRC. So we do know that. And so I did throw in here, just because you guys had heard from Westinghouse, just to kind of reflect back on that. And again, I'm not, their reactor, I think, is pretty well sized for this particular application and meets some of the basically the criteria that I think the RFP will end up focusing on, but it's not the only vendor that has a reactor design that would be appropriate for this. But this kind of gives you a little bit of an idea of the size. In this case, this is the reactor vessel itself. Theirs is intended to be above ground. Some have been proposed to be subsurface, but in this case, it would basically be the reactor core, and then the ancillary equipment for power generation and such are intended to be in like 4 really big shipping containers, basically oversized shipping containers is sort of the design for the eVinci reactor, just to give you guys sort of a feel for the size. And then this one uses heat pipes, like I mentioned previously. So the timeline for the project, for any of you that have kind of read the little info sheet that was put out with the news release, the idea would be that there'd be this draft RFP released for review before the end of this year. So that's sort of for feedback. And then it would be formally released in February of 2022 for vendors to bid on. And then that vendor would be submitted or would be selected in late 2022. And then, kind of going through beginning construction in 2025, and then commercial operation in 2027. So that's sort of the timeline that's been envisioned for this project. And I want to mention there's also this parallel project that's happening, which is slightly different, Project Pele. I think you guys may have heard about this before. And so this is a little bit different because it's a mobile nuclear power plant. So this is really like more geared toward needs of forward operating bases, as I understand it. And so this is really where the entire reactor can fit inside of a standard shipping container. And these are sort of the qualifications around this particular design, capable of generating power within 3 days of arriving at a destination, size to generate 1 to 5 megawatts again. So similar in that respect for 3 years at full power. Same kind of things related to passive cooling and TRISO fuel compatible. I mentioned that earlier. DoD originally awarded 3 development contracts, but since then that's been downscaled to just 2, the BWX and the X Energy designs. And then eventually 1 design will be selected to be built as a prototype as early as 2022. And where this would be tested or deployed is still a little bit of an open question too. There's a chance this could also happen in Alaska, but more recently I've been hearing about some other locations in the lower 48. So just in general, just looking at these small reactors and kind of looking forward to other applications in Alaska, the big ones that are worth thinking about are really remote communities, especially ones that are diesel dependent. And then whether micro-reactors in the future could also support mining operations, because you have the potential for both process heat and electric power. And one of the challenges related to the mining industry is ensuring they have power in some pretty remote areas, and that's always been a barrier for the mining industry. This is a map that we recently, yeah, go ahead.
We do have a question in the chat box. Is what they're talking about at Eielson at this point similar to what was being tried several years ago at Galena? And I think the answer is yes and no, and that certainly it's a different technology at a different scale.
Yeah, I mean, there's significant differences. It's a smaller reactor than what was proposed for Galena. That was actually one of the challenges with the Galena project, is it was a little bit oversized for the community, although at the time it was being proposed, the Air Force Base out there was still in operation. So they had a higher demand out there at that time. That system was designed to be installed subsurface. This is like on the surface. But I mean, in principle, I guess it's not really that different. If that Toshiba design had moved forward, and if it was still on the table today, it would probably be one of the potential candidates for this project at Eielson, in theory. So yeah, so this is kind of just a map that we recently developed that just kind of shows the remote Arctic, the off-grid areas of the Arctic. And so, if you look at Alaska, we have all these remote communities. The green dots represent communities that have a substantive portion of their power needs being met from renewables. And then all of the red dots are diesel dependent communities. Even a lot of the green dots are also heavily diesel dependent. And then you can also see some regional grids that are shown here. Map is a little difficult to see probably for you guys on the screen right now, but the point just being that this represents about 20% of the world's land mass, and there's about 1,500 communities that are not connected to the continental electric grid in either North America or Eurasia. And so this is an area where there's this constant challenge around importing fuel to meet local energy demand. I mean, of course, there's some examples of local energy resources that are being used, but that's a real opportunity potentially for micro-reactors, especially given the fact that they have the potential to meet heat demand as well, which is often a bigger energy cost than electric power is for residents in particular. Okay. So yeah, so I mean, there's a sort of this question here. We just did this is a reactor that's below ground to just give a schematic idea of what that could look like. But is there a future where micro-reactors replace diesel generation in Alaska and the Arctic? I don't know, right? But that's an interesting question. You know, I'm not talking about in 5 years, I'm talking about in 30 years. You know, is there a possible future where that could happen? And, you know, another thing to be thinking about too is Russia is moving forward pretty quickly with this concept as well. They have a lot of nuclear activity in the Arctic region. And one of them is that they're really starting to look at nuclear for community power. Pevek is a community that right now is served by these like kind of Russian, these kind of nuclear barges, you know, so that's just something that is of interest and that we're sort of paying some attention to as well. So I just wanted to mention again that working group, we already talked about that earlier. So please feel free to sign up. We'd love to have diverse stakeholders joining us for that. And that's all I have. So.
All right. And regarding the working group, again, I thought you said that they would be meeting next Tuesday.
Yes.
Yes.
They're meeting next Tuesday at 11:30 a.m. for an hour and a half.
Okay. And the guest?
The Nuclear Regulatory Commission. I'm actually not 100% sure who the actual speaker is, but it's the NRC.
All right. Well, thank you very much, Ms. Holdmann. You burned right through that. I feel certain there must be some questions regarding the content. So I would simply open up the floor. If anyone would like to go ahead and either raise their hand or just take themselves off mute and fire away, you may feel free.
Gwen? Can you hear me?
Mr. Gokey?
Yes.
Yeah. Gwen, I saw on your chart there for the military that it could hold up for 3 years. So what is the life of these micronuclears?
So that was in relation to this project Pele, right? So that's sort of like the qualification, the criteria that they're looking for from a vendor. But the idea is that these microreactors, and thank you for asking that because I did not cover this, are designed to not require refueling for somewhere between 5 and 10 years. Each manufacturer is a little bit different, and it matters like as to whether you're maximizing the output of the reactor or not. That's kind of why my question to a lot of the vendors is, okay, so if you're using that to regulate, you know, say wind energy, say at Eva Creek or something like that, and you're extending the life of that fuel, how does that actually interact with the economics of the overall deployment? So I have some questions like that. But the idea is that you would basically take the entire reactor as a whole. So you wouldn't refuel on site, but that you would take the entire reactor and ship it back to the manufacturer for refuel, bring a new reactor core in. And so there's like each manufacturer has slightly different views of how this would work. Like they would take a while to, you know, kind of fully cool down, like maybe a month or something like that. Then you remove it, but you've already brought a new one on site and sort of hooked that up. Like eVinci has the vision that a lot of these would be operated in two. So you'd have 2 stalls. So you might bring one in and then you'd have a second stall that you can bring a second reactor in so that you don't have an interruption in service. But that's sort of the general idea, that they're not refueled on site at all, that the whole reactor is removed. And then you bring a new one in and it happens on some cycle around 5 to 10 years.
So again, Project Pele is slightly different from what we're thinking about or looking at here regarding Eielson Air Force Base. Again, that was like essentially a single or double connex meant to be mobile and deployable, whereas this will be more of a fixed site, just small.
That's right.
So I expected this one. So we do have some questions regarding the fuel. Again, we're talking about you know, fissible material. So how is that transported, and or certainly the spent fuel, how is it transported and to where, or has that kind of thing been worked out? I think they're still working that out on the larger scale nuclear facilities as well.
Yeah, I mean, so there's this, you know, this problem at the national level in terms of what do we do with spent fuel, but the idea here would not be that there would ever be any spent fuel kept or stored on site. that would be removed with the reactor at the time where it's switched out for a new reactor. Now, one thing that's kind of there's like a question I think about like whether you can use recycled fuel, and there's been some confusion about that. One of the challenges with something like TRISO fuel that I mentioned is both like mechanically and thermally so strong, is it actually makes it pretty difficult to recycle that fuel for the same reason why it makes it pretty safe in terms of like having any kind of potential for contaminating the environment or being compromised in some way. So we're not really looking at opportunities, as I understand it, to be recycling fuel or using recycled fuel at this point in time. That's sort of not the vision, and there's been some confusion about that. But the idea would not be that the refueling would happen on site.
And so again, we're still working on a national level to figure out where we're going to, any spent fuel, what happens to it.
Gwen,
Mm-hmm.
I'm several things that I would like to see happen. The news media and the way this is presented is like the old nuclear situation, which is entirely unfeasible. This is a molten salt reactor, which I'm sure you know has some real safety considerations inherent in the process. And I think that we're not giving the public enough information. They're smarter than we're giving them credit for, I think. It's easy to figure out how these things are so safe because of the proximity problem with nuclear reaction. They have to be close enough. And with a molten reactor, that is automatically taken care of, because if it gets too hot, the molten salt expands and it loses proximity. That's how close they are. That sort of thing it would really help the public to understand why these things are so safe. That's only one aspect of it that causes it to be safe. The other thing is, what's really the problem in the United States and in the world really is our waste of energy. And molten salt reactors are built so that instead of having a 3% efficiency like the light water reactors that we've always have, only about 3% of that energy is used. The rest of it has to be stored. With molten salt, it's 95 or better percent of the uranium is used, or thorium, whichever, is used for energy. And the thing is, the way our electric and heat is generated now, you have to have a combined facility like the Aurora plant to use both heat and electricity to make it efficient. And we're not doing that in the United States. As a matter of fact, we've graduated away from that with gas. But with the molten salt reactor, there is an automatic efficiency. And some of that detail, now I'm making it probably too complicated, but that type of information needs to be transmitted to the public so that we're prepared to make this change. It's definitely got to be done in Alaska because energy is already in the rural areas is $10 a gallon, and it's going to go up significantly. They're going to experience this inflation that we've got to have to cover what we're spending. And so it's imperative that Alaska gets started in this communication as quickly as possible. I'm sorry, I'm taking too much time, but I've been interested in this for 50 years.
Well, Ross, I appreciate your interest in that. And that is a big part of why we're trying to put this working group together. I agree with you that, when people think of nuclear, they're sort of thinking about something that's different, very, very different than what we're talking about now. It's sort of like when you think of wind turbines, we have these like giant, like multi-megawatt offshore wind turbines that very little represent like the Danish kind of wind mills that used to be used for like, grain production and stuff like that. Like the technology has evolved like substantively, and with it, these sort of inherent safety features. I think one confusion is like, you know, you're mentioning molten salt reactors. Some of them are that, some are not, right? So this idea of like these advanced reactors actually cover kind of a plethora of like how you actually move the heat from the reactor core to use that for power generation or for district heating. So I noticed in the questions in the chat here, one question is, so there's this comment from Doug about, from Doug Smith about Project Pele potentially being tested at Idaho National Labs. I've heard that as well. I'm just not an expert. I don't know, but I'm not, at this point in time, I think there's still some questions around that, and I'm not really sure that, that it's just gonna be tested where it's gonna be tested. Jean, I think that you may actually be able to answer your own question better than I can. Jean Theriault, please expand on your thoughts that Eielson may not need to comply with Alaska statutes requiring state or local approval. This is something that I do think we just need to address. Like, we need to clean up our statutes. Again, they were mostly developed during a time where, as I understand it, there was concerns about nuclear proliferation. And so we need to kind of step back and say, are these still meeting the technology as it's evolved today, meeting the needs of Alaska? And so, like I mentioned, we've actually been working on a process to develop a bill to sort of go through systematically and clean up those statutes. I actually pulled out the slide that was relevant to that, but that's something that I think just needs to get done. And there is a little bit of urgency about that, in my opinion, given the timeline for Eielson. Any other questions?
If I could pop in here for a second, Gwen. I noticed both Daniel and Meadow are on board from GVEA, and I'd like to pose this out there that I've seen this similar presentation through the working group, and I had noticed that these reactors are, for practical purposes, use once and then throw away. We're not really throwing them away. We send them back to the manufacturer. We don't refuel them. We don't take them apart. We send them to the manufacturer. They send us a new one. It seems to me, given the size, that these would be perfect drop-in replacements for a Healy #1, considering that a lot of the piping is already there. We're not using so much of the heat for thermal as we do in the Aurora plant, where we're heating half of downtown. So I was curious that has anybody from GVA or even the manufacturers talk to you about how this can be used in a utility scale situation?
I don't know whether you're directing that question at me or to to Dan or whoever else is on from Golden Valley, but I'm gonna just take a shot at this and then they can chime in if they want to. One of the challenges is that these reactors don't exist today. Like, I just want to be clear about this. We are kind of on the cusp of these being developed and piloted and tested. But if Golden Valley wanted to buy a reactor off the shelf tomorrow and commit to purchasing one, there isn't one they can just purchase, right? And so it's pretty difficult for a utility to make decisions about their long-term generation mix based on a technology that we think is going to be available in 5 years, but there's still quite a few questions related to that, right? And so that's a challenge, I think, for Golden Valley. And they've got to make some decisions about Healy 1. There's some shorter term decisions that need to be made. I mean, we've even talked about investing the best in additional investment that needs to be made for the battery energy storage system that Golden Valley has. Could you use a micro-reactor instead, right? To regulate Eva Creek, for example. But a lot of these reactors are a little bit undersized for what at least a single module would be for what Golden Valley really needs to make a difference for their generation mix. And they don't know, like if they agreed to purchase one today, they don't know if it can be delivered in 5 years or 10 years. And so it's difficult to kind of make decisions at a utility level around that today. So I don't know if someone from Golden Valley wants to chime in, but that's my answer.
Go ahead, if just for a second. That's kind of what I wanted to hear, that there has not been much progress with response to, can I go buy it?
Mhm.
It is not off the shelf just yet. And that is the same disappointment I had 2 years ago or a year and a half ago with the working group. These are still proposed. They're a pie in the sky. I don't even think we have a working model yet. Is that correct?
Well, I would not say that they're pie in the sky, because just to be clear, like that, these can move along even quite a bit quicker than like modular reactors, like the new scale design. That we understand how to build a nuclear reactor, right? So it's really about getting it right and making sure we're safe. And the NRC is going to be risk adverse and should be around that, right? So we know how to build these. I think these are coming, and I think that Alaska needs to be paying attention. I agree, it never happens as quickly as you think it will. We've been talking about fuel cells up here as a possible power source for, you know, over a decade as well, and that's always a few years off, you know. So I think though that this is coming. I don't see this as pie in the sky at all, because even though we don't necessarily have a working reactor, a lot of the components that will go into that reactor design have been built, are currently being tested, have historically been tested. And honestly, even if you think about it, the very first reactors that we had, like the SM1 at Greeley, those were micro-reactors. You know, they just were not using this advanced, whatever advanced means. And I have a problem with that word, because I don't know what an advanced reactor is, but there are just a lot of different designs out there. I think these are coming, and Alaska should be paying attention. And if we're going to do an IRP process for the rail belt in 3 years from now, nuclear should absolutely be part of that conversation, okay? But I think the timeline that Golden Valley has to make certain decisions related to Healy 1 or the best replacement, those you cannot base an assumption that these micro reactors will be available in 5 years commercially. You can't base it on that. So that's my opinion.
Ms. Bailey, I saw that you were trying to take yourself off mute, or
I was just going to follow up real quickly and say that we do meet with manufacturers. We do talk about this technology as options that are out there. It's kind of, as Gwen mentioned, probably not part of the solution that we're looking for in the next couple of years and moving forward that quickly, but we are aware of the technology. We do meet regularly with different manufacturers to see what they can offer and what, you know, what they have, what their timelines look like.
a word that often comes up in these kind of discussions is ripe and ripeness. And you can have something that, again, that looks like it will make some sense in the future. It's just not quite baked or ripe yet. I know that IGU has that discussion often relative to the railroad and transportation of LNG using the railroad.
So
All
Jomo,
right.
I'll just answer one more question here that Steve Hagenson put in here, because this is exactly what I'm most interested in. So he asks, what's
Yes,
the
please.
typical turn down or minimum load for a 10 megawatt reactor? What's the ramping rate up and down, and how fast can output power be changed? So my understanding is that we're not talking about seconds. We're talking about within a couple minutes, that it can basically go from, like, say 50% to full output. These are just kind of rough constraints as I understand it. Some of these reactor companies are also doing an interesting thing where they're talking about molten salt. They actually have almost like a molten salt battery, so that they're actually kind of using the reactor heat to charge like a molten salt tank that then is used. And that's really what you're partially tapping for power generation. So you have a little bit of a different, like a buffer in there as well. So that's sort of generally what I'm hearing, but this is the piece I'm trying to understand a little bit better from the manufacturers right now. And they're all slightly different, which is part of the challenge. So.
Hey, Gwen, we have a number of further questions and comments in the chat. You want to just move through them?
Yeah, I can do that. So TerraPower is a really large reactor. So Doug is asking, are they interested in these scale projects? I have not heard anything about TerraPower scaling down their design. They're really more looking at that sort of grid scale reactor design. So I don't know. I have not heard anything about that, Doug. Now, some other manufacturers like NuScale have been talking about like a small version of their plant. So there's some discussion around that. But I have not heard TerraPower in particular talk about that. We are actually having a conversation with Kairos, I think tomorrow, actually. What we've been trying to do is with these, and they have a slightly larger reactor design. We at ACEP try to kind of approach these reactor companies and talk to them ahead of time with the idea of eventually bringing them in as a presenter at the working group, but we want to have like a preliminary conversation with them. So Kairos is the one that we're talking to this week, and they have like a 100-ish megawatt reactor design, maybe 120 megawatts, so a little bigger than what we're typically looking at here, but they have also another smaller version that they're working on as well. And I don't know, that is Alaska considered a nuclear testing ground? No, definitely not. But I think that the companies view Alaska as having some interesting potential applications and use cases, especially for these micro-reactor technologies. But certainly at the national level, there's not any kind of concerted effort to consider Alaska to be anything other than the rest of the country in terms of potential deployments. And, you know, a lot of these early testing and early deployments will occur at Idaho National Lab, most likely. So.
Hey, Gwen.
Yeah.
This is John Jackson. For those of you who don't know me, I do know you, Gwen, but I'm the National Technical Director for the Department of Energy's micro-reactor program. And I wanted to say, great job today. You covered everything very well. In response to a couple of comments, first of all, to Richard, and for everybody's general awareness, I wanted to bring to your attention the fact that at Idaho National Laboratory, we are developing a demonstration microreactor called the Marvel microreactor. It's not intended for commercialization, but it will come online before anything else. It'll be neck and neck with Pele. So it'll be an opportunity to really see one of these in action and understand how a microreactor responds on a microgrid, because it is intended to connect to a very small microgrid at INL. And to re-echo what you just suggested, Gwen, with respect to the Alaska considered a nuclear testing grounds, very much the National Reactor Innovation Center is located at Idaho for a reason. Idaho is more of a testing ground, if you will, because it's prepared to do that.
Thank you, John. I actually really appreciate that. I'll follow up with you as well. Thank you for joining us on the call today. That's great.
Absolutely. And I'm looking forward to next Tuesday's call as well.
Excellent.
All right, and just so we're clear, and I do also appreciate that. So whatever system is going to be tested somewhere else before it actually gets deployed at Eielson Air Force Base, at least as far as general concept?
That's not what you said, John.
But something is.
Well, yes, the Marvel microreactor that I was referring to is not a commercialized concept. It's intended to be a demonstration of the technology. It is fueled by Triga fuel, the Triga reactor fuel. It is a natural lead bismuth eutectic cooled system, 100 kilowatt rather thermal, 25 kilowatt electric. I can't speak for where the Eielson Air Force Base concept will be demonstrated. I simply don't know enough about it at this point.
Well, we don't know. There hasn't been a vendor selected for that project. So once that happens, we'll have a better idea of where they are with their development process.
All right. Well, this has been a great presentation. Now, Gwen, I do know that you said you had a 9 a.m. and we are at right at 9 a.m. Okay.
Well, if anyone has questions, feel free to reach out to me. Jomo certainly knows how to get a hold of me. I'm pretty easy to find too, and we'd love to have as many of you as are interested join the working group. That would be, like I said, I'm really looking for diverse perspectives and opinions. I want people that are a little skeptical of what this looks like, and people that are that are excited. We all need the same information so that we can all make good decisions about moving Alaska forward in this technology space and others. So that's really what the purpose of that group is. So please join if you have an interest.
Excellent. Thank you, Ms. Holdmann, and excellent comments there to conclude. So just to remind everybody, again, if you go to the ACEP website, and you can actually just Google ACEP Alaska, you'll get right there. There on the homepage, you'll find the link for that working group. It's over on the right-hand side, about halfway down through the list. You go ahead and click the button. It's easy to register. And so, yes, if anyone is interested, I know that I was and continue to be, you can get on board. But again, Ms. Holdmann, thank you so much for another great presentation. Thank you very much for your work generally regarding energy, but also again on this specific subject. You've been a major driver here in the state of Alaska, again, for keeping an eye on this. But keeping informed and helping the rest of the public be informed as it progresses. Much appreciated. Well, all right, everybody, that's it for today. I will try to get the links off of the chat and send them along with the recap. Just as a reminder, we do have a presentation scheduled for next week. It's actually going to be from Felix Gold regarding their efforts, exploration efforts around the Fairbanks community. And that's it for the day. So thanks a million, everybody. Again, thank you so much, Ms. Holdmann. Mr. Jackson, nice to meet you. I guess we'll be hearing and seeing you next week at the working group. Otherwise, everybody just have a great rest of your week, and we'll see you next week. Thanks, everybody. Well, there you go.